everyone. I am Royston, URK24CS1069. Now I am going to explain the data science and ecosystem experiment number 2, exploratory data analysis. In this first one, we are importing the CSV file as stores and displaying the first 15 rows. First we are importing, then we are displaying first 15 rows. In this program, I first import the pandas libraries as PD and numpy libraries. So the panda is used to work with the tables and sets. See, here are the tables and set. While numpy is mainly used for numerical operation, next I use the pd.read underscore csv function to load the store underscore pre.csv files into the data frame. Then named df. A data frame is a two-dimensional table with rows and columns. Finally, I use head15 function to display the first 15 rows of the data set so that I can quickly inspect the data. See, these are the data. First we have 15 we have imported. Then in second we are displaying the number of rows and columns. Uh, In the first question, I use the shape attributes of the data frame to find the dimension. The expression of df dot shape returns the total number of rows and df dot shape 1 returns the total number of columns. Prints these values that set database before performance of any analysis. And then we are displaying the statistical information. Here I use the describe function to generate statistical information for the data set. The first describe display statistics for numerical column such as count, mean, standard, deviation, minimum, maximum, quartiles. Then I use to display include object to display some information for categories. Then I use to describe include object to display some information for categorical columns. If shown data like count, unique value, the most frequent value and its frequency, this helps us to understand both numerical and categorical data. See, these are the data displaying statistical information. Then find the maximum total branch counted age and standard deviation. In this question, I prefer three different operations: find, max, find the highest value in total column. Next, count the number of non-missing values in branch column. Final STD, calculate the standard deviation of the age column, which tell us how much the age values vary from the average age. These functions provide useful statistical information about the dataset. Then fifth question, it is increase the price column by 20%. In this program, I increase every value in the price column by 20%. I multiply every value by 1.20% and store the result in a new column called updated price. This keeps the original price column unchanged while creating a new column with the updated value. Finally, I display both original price and the updated price column to compare the results. See, these are the price and the updated price we are comparing. Then count the null value and replace numerical null value with 0. I first check for the missing value using isNull.sum. This count the number of null value in every column. Next I used select dtype including numpy.num. bar to identify all numerical columns in the data frame. Then I replace the missing value in those numerical columns with 0 using the fill 0 function. Finally, I print the null value count again the confirmation that all missing numerical values have been replaced successfully. See, the numerical values are printed successfully. Then create a data frame. I create a new data frame manually using the pd.dataframe function. The data is provided as a list of dictionary where each dictionary represents one row of the table. Every key in the dictionary become a column name and every value become the corresponding cell value. This method is useful when creating a data frame without reading data from external files. See, these are the data from created from external files. Then group data by branch. I use the group by function to group the database on the branch column. After grouping, I select the total column and apply the age function to calculate multiple statistics at once. The sum function calculates the total sales mean, calculate the average sales, and max finds the highest sales of each branch. This helps us to compare performance of different branches. These are sum, mean, max. Drop the column with the most missing values. I first read the original CSV file into a new data frame named df2. Then I count the missing values in every column using isNull.sum. The idxmax function returns the column name with the highest number of missing values. After identifying that column, I remove it using the drop function. Finally, I display the first few drop function. Finally, I display the function few rows of the updated data frame to verify that the columns has been removed. Seeing these are the product dropped column and product lines. Then drop the 10th and 12th row. In this question, I removed the 10th and 12th row from the data frame. Since Python uses zero base index row number, 10 has index of 9 and row number 12 has index 11. I use the drop function with the index parameter to remove these rows. Finally, I display the first 15 rows to verify that specific rows has been deleted. See, in this first 15 row to verify and specific row has been deleted. Then displaying percentage of the unique values. I calculated the percentage distribution of unique value in the payments and product line column. The value counts normalize true function calculates the proportion of each unique values. The null 100 function converts the proportion into percentage and short values, arranges the result in ascending order. This means it's easy to understand the percentage shares of each category. See, these are the output for this. Then display the first n large and smallest value. I first assign the value of 5 to the variable n. Then I use the n large function to display the 5 rows with the highest value in the total column. After that, I used the n smallest function to display the 5 rows with the lowest total values. These functions are useful for quickly identifying the highest and lowest record in the dataset. These are the outputs. Filter rows using multiple conditions. I filter the data frame. First, I check whether the customer age is greater than 25. Next, I check if the quantity purchase is greater than 5. Finally, I check the rating is greater than 8. The operator is used because all three conditions must be true at the same time. The The operator is used because all three conditions must be true at the same time. The filter result is stored in new data frame called X. The head function displays the first 5 match record and the tail function display all the last 5 matches record. These are the outputs. Then display any 5 column using location. I used method to select specific columns from the data frame. The colon means that I want all the rows and the list inside the square bracket contain the means of the 5 columns that I want to display. These columns are branch, city, product line, total and rating. The location method is useful when selection data using rows and columns label. See, these are the outputs. Then check whether value exists using any. I check whether the value electronics accessories exist in the product line column. First compare operation check every rows and return either true or false. Then the any function check whether at least one true value is present. If the value exists anywhere in the column, the output is true, otherwise it false. Then calculate the square root using apply. I use the apply function to perform an operation on every value in the price column. The function np.square calculates the square root of each price value. These results are stored in a new column called price. Finally, I display both the original price column and the new price square column to compare the values. Create a copy and remove the payment column. I first created a copy of the original data frame using copy function. Copy function. Then the parameter in place true permanently removes the columns from the copied data frame. Finally, I display the first 5 rows to verify that the payment column has been removed. Create another copy and remove rows. I created another copy of the data frame using copy function. Then I use the drop function with the index 4 to permanently remove the rows whose index is 4. Since in place true, I used the change is made directly in the copied data frame. Finally, I display the first few rows to the confirm that the selected row has been deleted. Then display the age column from the 10 to 15. I use this method to select data based on the index position. The range 10 is to 16 selected rows from the index 10 up to index 15. Because ending index is excluded in Python slicing, after selection these rows I display only the age column. This is useful when retrieving specific rows and a particular column from a data frame. See, these are the outputs. Then find the mean, median and mode of the rating column. I calculated three measures of central tendency for rating columns. The mean function calculates the average rating, the median function to return the middle values after sorting the range, the mode function return the value or values that occur most frequently in the columns. These three statistical measures help summarize the overall distribution of the rating. Then rank transaction based on total. I rank all transactions according to the total amount. The rank function assigned to the rank of every values in the total column by setting ascending false. The highest total value receives rank 1 and the remaining values and are ranked in descending order. The ranking is stored in new columns called sales ranking. Finally, I display the total and the sales ranking column together to verify the ranking. Group the data frame by product lines and calculate total quantitative average price and average rating. I use the group function to the group that entire data frame based on the product line column. These lines that all rows belongs to the same product categories are placed in one group. After grouping the data, I used function which stand for to calculate multiple summarized value at the same time. First, I calculate the total quantitative sold for each product line using the sum function on the quantitative columns. Next, I calculate the average price using mean function on the price columns. Finally, I calculated the average rating using the mean function on the rate column. The results are displayed in new summarized table, where each row represents one product line along with its total quantity sold average. Average customer rating. This type of grouping helps us to compare performance of different product categories easily. Thank you. I use the pivot table function to summarize the data in table format. The values parameter specific that the total columns will be used for calculation. The index parameter groups the rows based on the product lines column, while the column parameter creates separate column for each branches. The function calculates the average total amount of every product line in each branch. The output is pivot table that makes it easy to compare the average sales across different product lines and branches. Then displaying the top 10 sales ranks. I use the n smallest function to display the top 10 record based on the sales rank column. Since rank 1 represents the highest sales, the smallest rank value indicates the best performing transaction. The function selects the 10 smallest ranking values and the displaying complete detail of those transactions. This helps identifying highest sales record quickly. Group by branch and payment. I use the group by function to the group. These are the output. This means the transactions are grouped according to the both branches and payment method. Next, I use a function to calculate multiple summary statistics. The average total is calculated using the mean of total columns. The average rating is calculated using the mean of rating column, and the total quantity is calculated using the sum of quantity columns. Finally, I used a sorted value function to sort the result in descending order based on average total columns. This allows use to easily identify which branch and payment method combination has highest average sales. Thank you.